If you get kicked out, come back in. I don't know why it does that sometimes, but sometimes it does. Now maybe it'll work. There we go. Okay, cool. So I wanted to give you a chance today to practice, but I want to remind you first that this is the last week to get signed up for See You Succeed if you are interested in the college trig credit. So make sure you do that. Okay, I think Friday is the last day. So, but get it done today if that's something that you haven't done yet and you want to. But other than that, your assignment for the day is already on Canvas. It'll be pages 20 and 21 in your guided notes. It kind of starts with graphs that look like this. And you are free to stick around and just do it right now and ask questions if you run into them, because there's a pretty good chance that you might. You know, as you work through the first page, it'll be pretty similar to what we've done in the past. Just be careful if they ask you for a limit versus ask you to just evaluate the function. But quickly, before you do go, in case you do decide, you know what, I'm good, I'm just going to try this on my own, flip to page 21 so I can explain what's going to happen there. So that it's more obvious, because like 4, 5, 6, and 7, pretty clear. There's a graph, you know, evaluate some limits or evaluate the functions. With page 21, numbers 8, 9, and 10 have you looking at that graph on the left there. But if you look at the instructions above that, it wants you to figure out if the statement is true or if it's false. Okay. Like for number 1, is the limit of g of x as x approaches 1, is it actually 2? If it is true, then just say true. But if it's false, describe why. You know, it's not 2, it's actually 5. Or it's not 2, it doesn't exist, and here's why, like that kind of thing. Same thing for 9, same thing for 10. Figure out if you think the statement that's there is true or false. And the thing that I want to make sure you understand clearly with number 9 especially is that the interval that they gave you from -1 to 1 does not include those endpoints. Okay, so keep that in mind as you work through that. And then for 11 and 12, you're going to try to sketch a graph that has those given limits or values for the function or whatever the case may be. So if you look at 11 and you look at 12, you're going to try your best to draw a picture where those things would be true. So like for number 11, the limit of f of x as x approaches 1 from the left is 3. Draw a graph where that's true. The limit of f of x as x approaches 1 from the right is -1, but the value of the function at 1 is 1. All right, so see if you can create a picture where all 3 of those things are true. And then same thing for number 12. You've got those 2 limits, and then it tells you that f of 2 is undefined, but the limit exists when x approaches 2. Okay? And then for number 13, they ask you to kind of peek back at your graph for number 11 and decide whether that limit exists or not, and then tell me why. And one quick sentence, it could be a sentence in Word or it could be a sentence in calculus notation, should do the trick. Okay, so stick around if you'd like. I'd be happy to answer questions as you run into them, or take off and you're good to go for the day. Just get this done sometime before midnight. Okay, we'll come back tomorrow and we'll go back to the tables. I just figured today's a good day on our shorter day to give you a chance to do your thing. Okay, so stick around if you'd like. I'm here to answer any questions that you have. And just submit this before midnight tonight, and I will see you tomorrow if you're headed off. Okay. Please ask questions if you've got them. Hey Jazz, what's up?
Hi. So I thought I understood, but I'm just a little confused. Can you just maybe go over the first two on number 4?
Of course,
I can
yeah.
figure out what I'm doing.
So, all right, so the limit, so the graph of h of x is given. Okay, so there's h of x. The limit of h of x as x approaches 1 from the left, right? Can you read that and kind of say that out loud? Okay. So what I want to do is I want to get close to this, but I want to follow the graph from the left and kind of think about what y value I'm headed towards. Looks to me like we're headed towards that hole at 2. So I would say that that limit is 2. But from the right, part B says, okay, the limit of h of x as x approaches 1 from the right. Okay, so I got to go right of 1. So I just kind of go a couple boxes. And I just start moving myself along the function, thinking about where I'm headed. And it looks to me like I am headed towards -3. And so when I get to a question like C, okay, well now what's the limit of h of x as x approaches 1? I think about these two answers. And if they were the same number, then yay, there's my limit, right? Because that's what makes a limit exist, is that the limit from one side is the same as the limit from the other. But because we're headed in 2 different directions, this limit does not exist. So that's why I kind of skipped a couple pages, because page 18 had other kinds of graphs like we did on page 17 yesterday. But what I really liked about this first question is it gave us the exact kind of mindset that if I want to answer a question like C, I have to think about A and then think about B, and then I can do part C. That's so crucial to my ability to understand limits. So when I do something like F, right? Okay, I want to get to -2. Okay, well then I'm going to approach -2 from both sides and kind of think about what I'm headed towards. So that kind of double-sided mindset is so crucial for us to be able to kind of understand these limits. I got to do it from one side, then do it from the other, and see what I get. Okay, do you want me to finish number 4? Or do you want to move on to the next one?
I think moving on to the next one would be good.
Okay. So now number 5 is a little bit different, because it doesn't say, okay, let's go to the same point from the left and then from the right and then think about the limit. It just kind of asks us a bunch of different ones. And so, okay, the limit of g of x as x approaches 0 from the left. Okay, so I go a couple boxes to the left and I just kind of track myself along this function and think about where I'm headed. And it looks like the closer I get to 0, the faster I'm headed down, down forever. So I could say something like -∞. Now, does not exist is also a really good option there, because we're not headed towards a real number. So if you said it does not exist instead, that would be perfectly fine. Because limits are real numbers, right? Actual real numbers that we want to get close to. Okay, so either one, -∞ or does not exist. I'm going to leave the -∞ up there because it just tells a slightly better story about what's happening. So if I didn't see this, I could really get a sense for what happens as I get closer and closer to 0. My numbers just grow in the negative direction, right? -5, -50, -500. I'm going to get closer and closer to 0 by going down forever. Part B says, okay, the limit of g of x as x approaches 1 from the right. So I'm going to go to 1. I'm going to go a couple boxes to the right. I'm just going to kind of track myself along the function and think about where I'm headed as I get closer and closer to x equals 1. And it looks like I'm getting closer to that hole that has a y value at -2. And that's just kind of what I'm thinking. I just kind of move myself along the function in certain directions and think about what I'm headed towards, right? So same thing for C, is x goes towards -∞. Well, I can't really go that far. So I really, when I see like x going towards negative infinity or x going towards infinity, I just think about, okay, like what does the left edge of the graph kind of look like? Or what does the right edge of the graph look like? So I'm gonna just kind of do this. Right? If I'm going towards negative infinity, the only thing I can do is just approach the left edge of the graph and see what happens. And as I do that, what I notice is that what I'm headed towards looks like a horizontal asymptote, right? They drew that dotted line in there that kind of gives me a clue that that's the end behavior in one of those directions. And that happens at y equals 4. But now look at D, right? Those first three were all kind of one-sided limits, right? 0 from the left, 1 from the right, and towards negative infinity, I can only do that from one side. I can't get on the other side of negative infinity. But with something like part D in number 5, you've got x approaches 4. Not from the left, not from the right specifically, so it must mean from both. Right? If they don't put the little plus or the little minus, we have to consider both sides. And so when I think about getting closer to 4, I have to kind of do this. I'm going to go from the left and from the right and see where, like, well, all right, what am I getting close to? If it happened like part C here, where I was headed in 2 different directions, then I would say, okay, that limit doesn't exist. But as you can kind of see, like my red arrows here, that as I track along the function towards that x equals 4 spot, it looks like I'm headed towards the same location, and I'm headed towards that hole at 1. Now, g of 4 and the limit of g of x as x approaches 4 doesn't have to be the same, right? And it's not in this case. Right? We've got a value for the function down here at this point that is not the same as the limit, right? I've got a totally different location for where my hole is versus where my point is. So sure, my limit of g of x as x approaches 4 is 1, but g of 4 is negative 3. Right, a totally different spot because we have that gap, that break. There's a discontinuity there, which is why my limit and my function's value could be in a different spot. Okay, and we'll just finish it up since we're here. Now think about going towards 3. So let me clear this up a little bit. All right, as we go towards 3, right, it doesn't say from the left or from the right, so we're going to do both. Okay, so I go a couple boxes to the left and I think about where I'm headed. I go a couple boxes to the right, and yeah, there's a hole there, but I got to get closer than that, so I'm going to keep going and get closer and closer and closer. There's no hole there, there's no gap there, there's no asymptote. There's just a point, right? The point 3, 2 is where I'm headed. And so, okay, 2, right? I'm going towards that y value of 2. And what's nice about that, and you'll see why we love that so much as we get a little further along, there's no asymptote or hole at that spot. It's just continuous, right? And so the value of the function and the limit in this case are just whatever the y value is at that exact point, which we like. And that might seem like almost too easy, that like we overthink that kind of thing, which is why I liked this kind of question, because it looked at, okay, let's go towards an asymptote, or let's go towards infinity, or let's go towards a hole, or let's just go towards a point, right? It's a nice graph. It's all connected in that space nearby. Cool. Then my limit is exactly whatever that y value is. Better? Sweet. All right. Yeah, I'll answer any questions that you have. So try some more now that you feel like you got the hang of it a little bit. I think, let me take a look without scrolling. Yeah, I think some more of these kinds of questions will kind of get you into that. Okay, am I approaching an asymptote? Am I approaching a hole? Okay, now I got to be a little bit more careful. But if I'm just approaching a spot on the graph where everything's nice and connected, then don't overthink it. It's just a y value at that spot.
Rosie, can you go over 6 and 7?
Sure. All right. All right, so we got some graphs, which makes it a little bit easier. We'll see tomorrow what we have to do with tables, and then after that, we'll start looking at actual functions themselves. But they give us a nice graph of f of x, so we can just look at it. And so when they ask us a question like part A, they say, okay, the limit of f of x as x approaches 0. It's not from the left, it's not from the right. So that means we have to look at both. And we have to see if we're approaching the same value. If we're approaching the same y value, cool, there's our limit. If we're approaching different y values or we're approaching like an asymptote, does not exist, okay? And so what I do when I think about a question like this is I kind of just consider them separately, right? All right, I'll go towards 0 from the left by tracking myself along the function, and I won't quite get exactly there, but I'll see what I'm headed towards. And it looks like I'm headed towards this point at 0, 1, okay? And from the right, all right, so I go a couple boxes, and I really don't need to go a couple boxes, because if I go up here, all right, well, then I run into this asymptote, but I got to get closer than that, so I got to come away from down here. All right, I want to get close. I want to get close. So I don't even worry about that half. I want to be really close nearby. So, I hop onto the other side of the asymptote. I get myself really close to that spot, and I say, all right, well, what y value am I getting close to from that side? Well, it looks like the same point, right? Because things are all nice and connected in that space. So the limit is 1, right? It's whatever the y value is that we're getting closer and closer and closer to. And we like that. It's nice and connected right there at that spot. There's no gaps right there at 0. There's no holes, there's no asymptotes, there's no nothing. It's all nice and defined and continuous. And so the y value is just whatever that point is. Part B, as x goes towards negative infinity. Okay, well, I can't go that far. I can't really go towards negative infinity, but I can go to the edge of the graph and just kind of see what's happening on the left. So I'm going to approach negative infinity from this side, of course. And all right, that's kind of the edge of my graph right there. And they drew a horizontal asymptote. And that's my clue that that's where I'm headed. All right, I've got the end behavior denoted by that horizontal asymptote, and now that tells me what my target is. And I know I'm never actually going to get there, but remember, limits don't care about if you're going to get there or not. It's about where you're headed. And what it looks like I'm headed to is that y equals 2 horizontal asymptote. And that's true for part C too, right? As x goes to infinity, okay, that's in this direction. Right, and so I can't get to infinity, but I can get to the right edge of the graph and just kind of see where it's headed. And I'm getting closer and closer to that asymptote. Sounds good to me. Y equals 2, again, where I'm headed in that direction. And now with D, E, and F, it actually breaks apart kind of the mental steps that we're going to take to find these limits. Like you can see, part D says, all right, let's go to 1 from the right. Part E says, okay, let's go to 1 from the left. And then part F says, okay, what's happening as we go towards 1? And that's what we're going to do. Like part F is really, okay, put part D and part E together and make a conclusion. Did you go towards the same spot? Cool, then there's my limit. Or did you go in different directions? Okay, then the limit doesn't exist, right? Or did I go towards an asymptote? Okay, the limit doesn't exist. And so when I think about going towards 1, like if I wanted to jump down to F, like right away, I really do part D and then part E in my head. Like I have to kind of consider both of them separately. Okay, so let's go towards 1 from the right. Okay, so from the right, looks like this. All right, I'm getting closer and closer to a vertical asymptote. Now, because I'm only going from one side, I can say that I'm headed up towards infinity. That's okay to say. Does not exist. Always a good answer in that space as well, because we're not really going towards a number, right? So that limit technically does not exist. One-sided limits are okay though. For part E from the left, right? So I'm going to go, I don't know, a couple boxes over and just see what happens as I get pretty close to 1. Well, that one's going down forever. Okay, so negative infinity might be a good way to kind of describe that just a little bit better than does not exist. But we are not headed in the same, like towards a single y value. And even if we were like both going up towards that vertical asymptote or both going down, that limit doesn't exist either way. This even more so does not exist because we're heading in totally different directions. So I say that D and E or does not exist, right? Because limits can exist or not. The value of a function is defined or not. Cool with that one? Sweet. All right. Number 7. No asymptotes here, but we do have some holes and some points kind of floating around a little bit, so we do want to be careful. There's a lot of discontinuity here that's worth considering. Okay, so part A gets right to it. It doesn't say approaches here from the left or from the right. It just says, okay, what's the limit as x gets close to 0? And that means I have to look at it from both sides. I gotta do both for this to work. Okay, so I'm gonna approach it from the left and approach it from the right. And I just think about them at the same time, right? And so I think about, okay, if I want my limit to exist in this spot, I have to approach the same y value. If I'm approaching different y values, the limit doesn't exist. And I don't care that there's a hole there and that there's no point at all. And I wouldn't care if there was a hole there and like the point was like way up here. Remember, the value of the limit does not care about whether the function's defined at that spot or not. It only cares if we're heading in the same direction, okay? And that direction is we are headed towards 1, right? That's the y value that we're getting closer and closer to from both sides. And so when it doesn't specify a one-sided limit, and none of these do here in question number 7, these are all just limits, you have to consider both. What am I headed to from the left and what am I headed to from the right? Has that idea sunk in for you guys sitting there? Okay, cool. All right. -3. So I'm going to get rid of this, change my perspective because now I want to go towards -3. And again, no plus or a little minus up in that superscript spot, so I have to do both. I'm going to go towards -3. Okay, so I'm going to do that. I'm going to do this. All right, and as I get really close, now I know like from -5 to -4, I was headed down for sure, but from -4 to -3, now I'm headed back up towards that hole. And when we think about limits, the thing that we have to realize is I know I'm taking us like a couple boxes away and we start to move closer. The reality is we should be starting really close and then just getting like closer and closer and closer and closer. Like I should really like start at like -3.5 and -2.5 and get closer and closer. It's just easy to kind of like follow the function a little bit further away. But the reality of the limit is that we are so close to -3 that it's indistinguishable from everything else around it, okay? And it looks like we're headed towards that hole, and the y value at that spot is -2. Again, I don't care that the point's way up there. That limit doesn't care about the value of the function, just about where we're headed. All right, same thing with C. We want to go towards 4, so I do it from the left, and I do it from the right, and I see where I'm headed. I'll let you answer that one. And I'll let you answer the same thing with x approaches -4. Okay, so there's -4, so I'm going to go this way. I'm going to, yeah, all right, fine, there's a hole there. I got to go past that. I know I'm actually not like following the function when I go through the hole there, but I just want to figure out what y value I'm getting close to. At -4, there's no gaps or holes in that space, right? Right at -4 and in this tiny, tiny, tiny little space nearby. So it's just whatever y value we're getting close to. So hopefully for C, you said 3. And hopefully for D, you said -3. And then for E and F, there's no limits there, right? It's just what is Q of -3? What is Q of 4? And so I'm just looking for the point, right? Evaluating functions is about finding points. Just telling me the y value at that spot. And so now I think about, okay, like where is the point when x is -3? That's kind of the question there. Oh, that point's right there, right? Nothing to do with the limit at that point. I'm not approaching anything. I'm going directly to that spot. Remember, calculus happens in motion, right? I move towards a certain spot. Evaluating functions is very static, right? I just look at the picture and I find the point. I don't do any motion. I just go right to it. I go right to 4 and say, that's where it is. All right, same thing with Q of 4. I don't care that I'm going towards 3 from the left and from the right. Where's the point? It's right there. At x equals 4, I get a y value of 1. And that's kind of the thought process. So hopefully hearing that out loud again, this is day 3 now of us working through these ideas, it starts to sink in a little bit better. Good with that? Questions? Awesome. Cool. Page 21 definitely challenges us in a different way, right? Now that you've done these 4, okay, now can I change the way that I think about limits? Like, can I look at a graph and look at statements about that graph and decide if they're exactly true or if they're not? Or can I look at like a statement? All right, here's a limit, here's a value, here's what we know. Can I create a picture where that kind of thing is true? So being able to kind of approach these ideas from different angles is so crucial in calculus that that's why I wanted to kind of put page 21 out there for you to give a shot. So see if you can do that. And we'll go over it tomorrow for sure before we back up and look at the tables really quickly. Tables are not a huge thing for me, but it can be nice just to kind of get a sense of what these look at. These tables just are, they're just okay, and I don't love them. So we'll just do them for Thursday, and then we'll kind of move on a little bit. I don't even know if we'll spend all of Thursday looking at tables. We'll just do a couple just so you can kind of get the hang of it. But connecting graphs to limits, definitely more important. And then being able to say, okay, now that I got these graphs under my belt, okay, what does that mean analytically? What does that mean algebraically? Can I just look at a function and find some limits? There you go.
Rosie, how would number 9 work with the interval?
Okay, so the thing about 9 is we're trying to figure out, okay, so between -1 and 1, does the limit exist for every single number? So does it work for -0.9 and -0.8 and 0 and 1/3 and 5/7 and 0.9999999, all that stuff? Now I don't care about the limit actually existing at 1, right? Because they didn't put the hard brackets around it, which would include it, right? They just did the soft brackets. So I don't have to worry about the limit actually existing at 1. Because if I went to 1, I'm definitely headed towards different spots, right? So that would be false. The limit does not exist at 1. But at every point between, and also, I mean, we haven't really talked about this at all either, but the limit at -1 also doesn't exist because from the right I'm headed here, but from the left, I've got nothing. I've got no function to follow, so that limit doesn't exist because I can't go anywhere, right? I have to approach it from both sides, and I can't do that if I don't have a piece of the function. So the limit at 1 definitely doesn't exist. The limit at -1 definitely doesn't exist. But what about all the space in between? What about all of those numbers? And so let me see if I can do it. Like, imagine being, so there's the point at 1, right? And the reason why I am so close is because we have to imagine really being this close. And so, like, you know, there's a point like right here, right? There's a point right there at 0.9999999, right? So super close to 1. But if I'm at point, so 0.999, whatever, however many nines I feel like saying, are there any points between this x value and 1? Are there points between those two numbers? Since the graph is all connected, is there a point at 0.9999991? Or 9999994? Or 9999999? Sure, right? And there's also a point here, and there's a point here, and a point here, and a point here, and a point here, and a point here, forever. And so although the space is very small, what we realize is that if I wanted to find the limit of f of x, or whatever it is, g of x, as x approaches this number, this finite number that has like 12 nines in it, what we have to start realizing is that there is space between that number and 1. And if I've got space on both sides, then I can approach that 0.9999999 from both sides. And if I can approach that same y value, then the limit's going to exist. Now, I mean, reality, right? We're not looking at it. This is hard to do. There we go. All right, we can't look at it really that closely. But we have to start doing that mentally. We have to realize that, okay, so like if there's a point here, do I want the limit, like does the limit exist? Sure, because from the left and from the right, I'm approaching that same point, right? It's all connected. You know, and what about a point like right here, right? Does the limit exist at that, whatever that x value is right there, like, you know, at 0.8 or whatever? Yeah, sure, because from the left and from the right, I've got space to approach that point from both sides. And because things are all nice and connected, continuous, because things are continuous, the y value is whatever the limit is, right? Those two are going to be the same because there's no hole, there's no gaps, there's no asymptotes, there's no breaks, there's no nothing. But imagine doing that right here, right? At that point, 99999999999, right? I can approach it from the left. And in a very small space, but a very measurable space, I'm going to draw it way bigger than it is, but I can do that, but I can only do it from like right there. But I have space between any x value in that interval on the left side and the right side. The moment I actually get to 1, well, okay, now in order for me to approach it from the right, I have to come down here to do it, right? And I don't want to do that, which is why they couldn't include those endpoints. And so I don't know if any of that explanation has gotten you to the answer, but the answer to number 9 is that it's true. The limit exists for every value on that interval because I'm not including the endpoints and the space between is continuous. When you have no holes, no gaps, no breaks, no asymptotes, when things are continuous, and you don't include the endpoints, the limit will exist for every value in between there. Does that make sense? Jazz, what do you think? Are you listening? Okay, cool. So that's why, for me, I believe in the truth behind number 9. And that's the kind of idea we have to start wrapping our heads around, is like the infinitesimal, the smallest space you can think of, and then get smaller. But realizing that space is still measurable, that I can go to the left and to the right of any point in that interval. But the moment I block off something like 1 right there, now this statement is false. Or the moment I block off -1 and I include that endpoint, now the statement is false. So the big difference between closed intervals like the one I just wrote in blue versus the open interval which they gave us, that very small change makes astronomical differences in what we can do in calculus. Yeah.
Thank you, Rosie.
Thank you.
Yeah, you're welcome. See ya.